Contact has been lost with Opportunity since the 12th of June 2018. This pioneering rover survived an incredible 15 years on Mars's harsh surface, when finally a global dust storm blocked the sunlight from hitting its solar panels for several months. This video is a recap of Opportunity's entire mission, from its first landing to the final dust storm, with all the challenges it overcame and discoveries it made along the way. By the end of this video, I think you'll agree with me that it was a remarkable mission and that it contributed a huge amount to our knowledge of the Red Planet. And it's this knowledge that has paved the way for the missions we are seeing today, like Perseverance. It answered questions like, did Mars once have a more substantial atmosphere? Did it have huge bodies of liquid water on its surface? And was it once more like Earth? And if so, what changed? I'm McColgan and you're watching Astrum, and together we will follow the record-breaking journey Opportunity took on Mars. Let's start right at the beginning. Having launched on a Delta II heavy spacecraft, Opportunity landed on the other side of Mars from its sister rover Spirit, about 3 weeks after Spirit had already landed. Opportunity used a parachute to slow itself on its descent, and fired some rockets just before it landed. The effects of the rocket firing are evident from this lighter patch of ground, as seen by the Mars Global Surveyor. Opportunity first bounced, and then came to land inside a tiny 22-meter crater, now known as Eagle Crater, with the heat shield and parachute ending up a few hundred meters away. NASA scientists were so excited by this that they called the landing a hole-in-one, although they weren't actually aiming for this crater. They didn't even know it existed until they got there, as Opportunity actually landed about 25 kilometers away from its intended target. As Opportunity emerged from its protective shell, the first thing it did was have a look around. Opportunity is equipped with a panoramic camera, which it can use to survey the area. It saw some outcrops only a few centimeters tall, made up of extremely fine dust, each grain far smaller than the grains typically found in Earth's sandstone. Opportunity and Spirit were primarily on Mars for its geology, the end goal being to see if Mars was ever a place that was conducive to life. The way that they did that was by looking at rocks for evidence of water, thus giving scientists an idea of what Mars might have been like millions of years ago, as rocks contain clues about their history. Opportunity explored the outcrop closely over the course of the next few weeks, already discovering evidence that in the past some kind of moving current had made the bedrock dip, although it wasn't clear if it was water that had done this, or volcanic flow, or wind. You can see this in this image, as the thin rock layers are not parallel to each other. On Sol 30, or Opportunity's 30th Martian day on its surface, it got close to the outcrop and used its rock abrasion tool to drill into a section of the rock face. As it did so, it found something known to geologists as vugs, or voids in the rock, the result of crystals having been eroded away. The rock also contained hydroxide ions, meaning water was likely present when the rock formed. Next up for Opportunity was to dig a trench in the soil for further analysis. It did this by digging its front wheels into the soil while the back 4 wheels held it in place. After some shuffling about for 22 minutes, it had made a trench 50 centimeters long and 10 centimeters deep. Under the top layer of soil were some things it had not seen before, including shiny little pebbles and grains so small this microscopic image can't even distinguish between them. Over the course of the next few Martian weeks, having discovered everything it needed to, Opportunity powered out of the crater at an average speed of 1 centimeter per second, and headed towards the next biggest crater in the vicinity, Endurance Crater, which is about 200 meters wide. On its way, it passed by this tiny little crater called Fram. It took a photo, but didn't stop for long. On Sol 84, it reached the edge and had a look inside. Mission planners already knew that Endurance had many layers of rock to be investigated and wanted to have a closer look at them. Opportunity circled around the crater looking for a good entry point, as getting in wouldn't be a problem, but getting out might. By Sol 127, mission planners decided to drive Opportunity into the crater even if it couldn't get out, as the value of science that could be garnered was too promising to pass up. So, on Sol 131, it carefully edged its way over the ridge of the crater and tried to reverse back to see if it could. Luckily, the angle of the rim was only 18 degrees, well within Opportunity's known safety margin, so the excursion into the crater began in earnest. Opportunity went on to spend 180 sols in the crater. It explored an area called Karatepe, where it saw various layers in the bedrock. It went near to, but not into, some sand dunes, as mission planners didn't want it to get stuck. It saw some wispy clouds similar to Earth's cirrus clouds. And lastly, it went to a cliff face called Burns Cliff, an impressive looking cliff face with various layers separated by broken up rocks and dust. It finally left Endurance on Sol 315. During the time there, the data collected by Opportunity meant that scientists were able to confirm that water didn't just cover this area once, but it was in fact episodic in nature, with floods that would have washed across this landscape before drying up again. At any rate, the water here would have never been that deep. After that substantial discovery, the next stop on its adventure was to investigate its own heat shield. On the way, it came across a rock that was later confirmed to be a meteorite named Heat Shield Rock. It was the first meteorite to be identified on another planet. Opportunity then set a course for Erebus Crater. It pressed ahead through a region called the Etched Terrain to search for more bedrock. While traversing this area, on Sol 445, Opportunity got stuck in a 30 centimeter sand dune. Things did not look good for the rover. All 4 of its corner wheels were dug into the dune by more than a wheel radius. This dune came to be known as Purgatory Dune. It stayed motionless for just short of 20 Martian days as mission planners frantically tried to figure out how to get it out. They simulated the scenario on Earth and tried various methods before they ordered Opportunity to try anything. On Sol 461, the rover advanced a few centimeters to see if it was doing what their tests had predicted. Over the course of the next 20 Martian days, Opportunity moved a few centimeters, took a photo of the progress, and sent the results back to Mission Control. By Sol 483, Opportunity had successfully escaped the dune and all 6 wheels were on firmer ground. It would have been disappointing if it had travelled for a year on Mars just to get stuck by a 30 centimeter dune. Opportunity studied Purgatory Dune for another 12 Martian days before setting off again on its way to Erebus Crater. During its journey, mission controllers uploaded updated software to Opportunity to prevent it from getting stuck again. With software designed by learning what happened from the experience at Purgatory. With this new software update, it was ready to carry on its adventure at Erebus Crater. As Opportunity approached Erebus, it came to sections of ground where the bedrock was exposed. Mission controllers named this section the Erebus Highway. As we know, Opportunity's main mission was to search for signs of water on Mars, clues of which can often be found in the planet's rocks. It used its rock abrasion tool to carve circles into the bedrock, and with its microscopic camera, it compared the different structures of the rock to search for evidence of water. You'll notice by here that Opportunity's tracks are in front of the rover. This is still the front camera, but sometimes mission controllers drive Opportunity backwards to even out the wear and tear on the equipment. Erebus is a very old and eroded crater, filled with sand with only a few outcrops showing. You may not have been able to tell it's a crater from the ground perspective because it's so shallow and eroded. It only really becomes visible from the satellite photos. It is about twice as big as Endurance Crater at 350 meters in diameter. but Opportunity never actually went inside the crater as there was only more dunes in it. Instead, it stuck to the rim, avoiding larger dunes as it went. Even while carefully maneuvering around these dunes, it hit some soft sand and its wheels sunk in. Luckily, the software that was installed only a few weeks previously noticed that the wheels were slipping and it stopped its drive command. You see, Opportunity is not controlled in real time by a person on Earth with a joystick. There is too much latency for this, between 6 minutes to 40 minutes depending on the proximity of Earth and Mars. So instead, Opportunity is given drive commands. Using these same navigational images you see here, and comparing it with satellite-based imagery, mission controllers command Opportunity to drive forward a certain distance, where it will then take a new photo to show its progress. The software that prevented Opportunity from getting stuck meant that mission controllers could get the rover to reverse out without another several-week delay. During Opportunity's time there, it collaborated with ESA's Mars Express orbiter. The Mars Express images the surface of Mars from orbit to search for different types of materials. Without actually sampling the surface, the data it collects can be hard to interpret. Opportunity, however, can physically interact with the surface material, confirming whether what the Mars Express data showed was correct or not, helping them to refine their future observations. While Opportunity was near Erebus, it was also able to see an incredible transit of the Sun from Mars's closest and biggest moon, Phobos. As it was still making its way around Erebus crater, a big dust storm hit, and Opportunity went dark for a few days. Very interestingly, you can see the difference the dust storm made to the rover as the camera goes from having a clear image to having some dust particles visible. Also, dust settles on the solar panels, meaning it can't generate as much electricity. Very fortunately though, Mars has occasional cleaning events, where wind or even a dust devil will pass over the rover, blowing the dust off the solar panels and camera. Because Mars is so dry, this dust is not at all adhesive, and the dust is so fine, almost as fine as cigarette smoke, that it doesn't take much at all to shift it off. You can notice this cleaning happen over time too if I speed up the footage. Look at this fleck of dirt here and how it disappears over time. Opportunity doesn't have a means of clearing this dust off by itself, so it has always relied on these cleaning events happening, which thankfully over the course of the 15-year mission they did. Sadly, however, during the time at Erebus, Opportunity encountered its first mechanical fault. Its arm was getting stuck all the time, as you can see here. There was a broken wire, although the motor still worked if it was given more power. After careful deliberation, engineers decided the best thing to do would be to only stow the arm away while traveling long distances. Over short distances, it would be kept in a hover stow. This replica is being used to test how it can travel with the arm out in this hover stow position, where the arm is out but it bends back at the elbow towards the rover. They thought it would be better to have the arm stuck while it was out rather than to try and stow it away to find it can never be used again. At least it would be somewhat functional like this. Over the course of the mission, up until this point, it was also encountering a problem with a heater for a motor in the arm that wouldn't turn off. Engineers managed to get away with switching it off with a T-stat switch, meaning a thermometer switch would cut power to the heater if the motor got too hot. But as Martian winter drew near, there would be less sunlight. There wasn't enough power to have the heater on all night. They fixed this by completely disconnecting the batteries at night. This led to another problem, where there would be very big swings in temperature between day and night, meaning the motor would likely wear out faster. At this point in the mission, this motor stalled altogether. Engineers temporarily fixed it by applying more current through the motor, although as a precautionary measure, they stowed the arm outside the rover at night in case the motor permanently stalled. You'll start to notice this in the camera view from now on. By February 2006, or Sol 744, Opportunity visited its last site around Erebus crater, called the Payson Outcrop. This outcrop of fine layers shows a diverse range of primary and secondary sedimentary textures formed billions of years ago. The structures that were observed here were likely caused between a mix of wind and water processes. By Sol 766, Opportunity had left the rim of Erebus and was on its way to the biggest and most impressive crater yet, Victoria. It journeyed through large ripple sand dunes, a type of dune we don't have on Earth. However, Opportunity tried to stick to paths of exposed bedrock, as these are much easier to traverse, and it can stop and investigate along the way. These cobble fields are a bit of a mystery, as we are unsure how they formed like this. On Sol 833, Opportunity almost got stuck again. Previously, mission controllers were thrilled by the meters of progress per day Opportunity had been making towards Victoria, but in this sequence it took 4 days to get out of this dune, which they named Jammerbugt, a Danish term for the Bay of Wailing. Nearly 200 Martian days after it left Erebus, it arrived at Victoria, and what it saw was amazing. High ridge walls, a steep slope in, and beautiful sand dunes in the center. It had already overcome so many obstacles, and this site was the reward at the end. So, what was so interesting about Victoria Crater? Was it able to provide any valuable information about Mars that Opportunity hadn't picked up anywhere else? Victoria was always going to be an important landmark for Opportunity to reach. Although few thought Opportunity would last the 7-kilometer journey from its initial landing site. At this point, Opportunity had lasted more than 10 times longer than its original design lifespan. Victoria is the biggest crater Opportunity had visited yet, being 730 meters wide. It was also the deepest, meaning ancient bedrock outcrops along the walls of the crater were exposed to the surface. Exposed bedrock contains the clues to Mars's past that Opportunity was looking for. Also, as you can see, Victoria made for an impressive sight, especially in contrast to this otherwise flat plain that Opportunity had landed in. In preparation for this new exploration site, mission controllers uploaded new software to the rover, which would enable it to decide whether to send back an image or to extend its arm in preparation to sample an interesting rock outcrop, and even improve the intelligence of the rover to detect obstacles it should avoid and to make its own path around them. Who would have had to have gone through hundreds of images and wait through painful latency delay for commands to be sent to the rover. At its furthest point, the latency between Earth and Mars can be upwards of 40 minutes. This is one of the reasons why it took 3 years to only travel 7 kilometers up until this point. To test this new software update, mission controllers had Opportunity drive towards a patch of rubble, and settings were adjusted to make Opportunity think that this rubble was a no-go zone. In reality, the biggest of these rocks is only 10 centimeters tall, meaning Opportunity could have easily driven over it. But they didn't want to test the systems on something that could actually damage the rover if it went wrong, so they chose these rocks instead. As you can see, the rover adjusted its course around the dangerous area and took this panorama so mission controllers could see how the rover responded to the new program. Opportunity began to circle the outskirts of the crater, imaging it as it went. It came across a few cliffs or capes along the way, imaging them with a very clever technique called a super resolution mosaic. These images have a much higher resolution than the camera on board Opportunity is capable of, and the way they did this was by taking lots of photos of the same thing, and then in post-processing on Earth, they combined the images to provide the resolution you see here. On a side note, this technique is used in many different fields, including microscopy and astronomy. Scientists say that the layers you see in the rocks found in all these cliff faces are due to a geological process called cross-bedding, They believe these layers are ancient sand dune deposits, which is why the lines are inclined upwards and not just horizontally. From these lines, they predict that this used to be a sand dune field not unlike the Sahara Desert on Earth. While this science data was very useful, mission controllers were primarily looking for a passage down to the crater floor, and they thought they found one here by the Valley Without Peril. On closer examination though, it was decided that the slope was too steep. Opportunity investigated a couple of cliffs while it was there, and even came across another meteorite called Santa Catarina, before mission controllers decided to drive the whole way back to the original arrival point at the crater to try and head down by there. This site was chosen because the slope was within the safety limits of the rover, plus the ground was made of flat, exposed bedrock, which meant it wouldn't have much wheel slippage. On the 28th of June 2007, or 1,200 sols into the mission, Opportunity prepared itself for its descent. But just as it perched itself on top of the slope, the biggest dust storm Opportunity had seen yet rolled in, decreasing the brightness of the sun by 96%. That's not quite as bad as it sounds, as the dust also scattered some of the sunlight towards the rover too, meaning it was generating 128 watts on the darkest day compared to its usual 700 watts on a clear day. But this is bad news for a solar-powered rover. That kind of power level isn't enough to keep the rover going. In fact, anything under 150 watts means the batteries begin to run flat. So operations were cut back substantially until the storm was over, and Opportunity was commanded to only communicate back to Earth once every 3 days. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors have heaters powered by the batteries during the night to keep the motors warm. If the batteries run flat, there would be nothing to stop there being extreme temperature differences between the night and day. At the equator, anything up to 20 degrees Celsius during the day and minus 75 degrees Celsius at its coldest at night, which would damage the sensitive components. The reason for this temperature variability is because, although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. Going back to the batteries, if they reached a critical level, Opportunity was also designed to trip a low power fault. This basically disconnects the rover's batteries from all but the most essential systems of the rover, putting it to sleep as it tries to charge its batteries with whatever available sunlight there is. Every sol, the rover would check the battery level to see if it could reconnect the other systems, and if so, it would then re-establish communications with Earth. This low power mode could mean that the rover stays asleep for only a few days, but it could also go on for weeks or even months. Chances are at that point, even if it did switch back on, too many of its components would be broken and it wouldn't be able to function anyway. Back to the dust storm. At the start of July 2007, mission controllers initially thought it would only last a week, but by the 15th of July, the storm had reached its peak. These are true color images showing a time-lapse of the storm, and as you can see, it does get very dark. Thankfully, the severity of the dust storm was not quite enough to trigger the low power fault this time, although it did get worryingly close for a while. Eventually, by the 21st of August, or Sol 1271, the storm had cleared enough so that Opportunity could start to move forward again. Sol 1291 saw Opportunity finally enter the slope of the crater, but like it did before with the previous crater, just after it entered, it backed out again to assess the amount of wheel slippage from the slope. As it happened, wheel slippage did exceed the mission controller's threshold of 40%, so the rover stopped with 2 of its wheels still over the lip of the crater. After 2 days of decision making, mission controllers decided to press ahead regardless, and an extended exploration into the crater began. As Opportunity descended, it took some time to investigate any interesting looking parts of the exposed bedrock. It also took some images of the cliffs on either side of it. I think these images showcase just how steep this slope that Opportunity is sitting on, roughly 20 degrees. Opportunity didn't venture too far into the crater, as only sand dunes were found towards the base. It spent its time examining this light patch of bedrock, taking various pictures and using its rock abrasion tool to investigate the rock structure. It was determined from the data Opportunity collected that this area was likely not ever so hospitable to life. So mission controllers picked the next waypoint on their journey, Endeavour Crater. If you thought Victoria was big, look at this mammoth. Endeavour was thought to contain some clays, meaning water was once there, so Opportunity started its journey out of Victoria. At this point, on Sol 1502, Opportunity encountered another fault with its arm. No matter how much power they put into the joint, the arm wouldn't move from its stowed position under the rover. Sol after sol passed and the joint refused to move, until they determined the time of day the joint had the least electrical resistance, which was just at dawn before the heater for the motor switched off during the day. When that time came, they put as much power as possible into the motor and it worked. Not risking ever stowing it away again, engineers had to determine how to maneuver the rover safely without risking damage to the arm. Opportunity then began its 2-year trek towards the Endeavour Crater. This is Endeavour Crater, a huge but shallow crater at 22 kilometers across and 300 meters deep. But why Endeavour Crater? Due to the distances involved, it would take a long time for Opportunity to get there. So what's so special about this place compared to anything Opportunity had seen before? The most compelling reason, and indeed one of the science goals of Opportunity, was to find evidence of past oceans on Mars. At this point, in 2008, the theory that Mars once held an ocean on its surface was only just starting to get solid evidence thanks to the Spirit and Opportunity rovers. Opportunity at this point had discovered that water once existed on the places it had visited, but these places were no more than shallow floodplains which dried up periodically, not a true ocean. On the other hand, the Mars Reconnaissance Orbiter had spotted what was believed to be clays around Endeavour Crater, clays being hydrated minerals which could have only formed from water being on the surface for extended periods there. Could Endeavour have been part of a more permanent ocean? And if there really was a surface ocean, are there clues to indicate that it could have harboured life? Mission controllers had to find out. And so, Opportunity left Victoria Crater and began its arduous journey south. The mission team were determined to reach their destination as quickly as possible, while also keeping a lookout for anything of interest along the way. Opportunity made good time across the Meridiani Plains, and by Sol 1818, it had travelled more than 3 kilometers. Nothing noteworthy really happened until Sol 1947, where a large rock was spotted. The mission team decided to investigate, discovering that it was a meteorite which they named Block Island. In fact, large rocks seemed to be the only thing to keep Opportunity busy, later spotting another one called Shelter Island, and a third called Marquette Island. Marquette Island was of particular interest to scientists though, as they believed this rock was part of the ejecta from a large meteor impact, meaning this rock would have come from deep in Mars's crust. Scientists could tell because the grains within the rocks are coarse with a basalt composition. The coarseness indicates it cooled slowly from molten rock, allowing crystals time to grow. Had it formed near the surface, the crystals within it would have been a lot smaller, as it would have cooled a lot quicker. Opportunity was never alone on Mars. It had a sister rover named Spirit, which was exploring the other side of the planet at the time. They both landed on Mars at roughly the same time, and had both far exceeded their original expected lifespan of 90 sols. At this point, they were 1,900 sols into the mission. Although, just like Opportunity up until this point, Spirit had encountered some mechanical failures too. Most notably, one of its front wheels jammed only 700 sols into its mission, meaning it dragged this wheel along as it travelled. In a way, I almost think Spirit was NASA's darling between the two rovers. Spirit often got more media attention for the things it was discovering on the planet. However, it was around the time Opportunity explored those rocks that Spirit, on the other side of the planet, attempted to drive over a sand dune and got its wheel stuck deeply in the sand. Spirit's operators began the long process of attempting to get it unstuck through simulations and testing on Earth-based replicas. Meanwhile, Opportunity carried on its long journey to Endeavour. By Sol 2138, Opportunity finally reached a landmark of note, Concepcion Crater. It is only 10 meters wide, but probably the youngest crater visited yet, evidenced by the exposed rubble and ejecta. Nothing particularly new was found there compared to any of the bedrock Opportunity had examined in the past, which was simply sulfate-rich sandstone containing peppercorn-sized spheres known as blueberries. At least the crater provided a contrast to the vast expanse of rolling sand dunes. 8 months had passed since Spirit got stuck in the dune. The sand that enveloped its wheels was particularly fine, and the process of excavating Spirit was exasperated by its jammed wheel. During this recovery process, another of Spirit's wheels jammed, meaning only 4 of the 6 now worked. The Martian winter approached for Spirit, and it was getting less and less sunlight to power its batteries, until finally a low power fault occurred on the rover and its systems disconnected from the battery. Spirit went silent. Mission controllers attempted for months afterwards to regain contact with the rover, but NASA eventually called an end to Spirit's mission. For the first time since it landed, Opportunity was now alone on Mars. Opportunity's long slog over kilometers of sand dunes to reach Endeavour was becoming taxing for the rover. Perhaps overly anxious not to have a repeat of what happened to Spirit, mission controllers decided to reroute Opportunity's course, a longer route, but hopefully a less arduous one. This route would also take it by what was named Santa Maria Crater. By Sol 2244, Opportunity set a new record for the longest lasting mission on Mars, finally beating Viking 1's mission duration. Opportunity could begin to see the rim of Endeavour, spotting the landmarks of Cape Tribulation, Cape Byron and Cape Dromedary. However, even 100 sols later, it was only halfway to Endeavour from Victoria. It had made good time considering it has a top speed of 5 centimeters per second and often went half of that to be safe, with frequent stops to look out for potentially problematic sand dunes. You'll notice the rover's tracks are ahead of the rover in this time-lapse. This is because there is also a navigational camera on the back of Opportunity, allowing it to drive forwards or in reverse to evenly distribute wear and tear on the motors. Although, another reason right now was to protect Opportunity's extended arm, which, as I mentioned in the last episode, got stuck in this position. On Sol 2449, Opportunity finally arrived at Santa Maria Crater. It's a 90-meter wide crater and was important to mission controllers as there was already evidence here of hydrated sulfate minerals. As I mentioned, hydrated minerals can only form under bodies of water over extended periods of time. So this was an exciting precursor to what they really wanted to investigate around Endeavour, which was still a tantalizing 2-year journey away. Opportunity also stopped here to take a spectacular time-lapse of a Martian sunset or two, with one of the time-lapses showing a transit of Mars's biggest moon Phobos across the Sun. Over 2 years had passed in just this one episode. Opportunity had soldiered on well beyond its expected mission lifetime of 90 sols, and even outlived its sister rover Spirit. It and the mission team had earned a rest at Santa Maria, and they all spent 3 months happily examining rocks and unlocking secrets about the history of Mars. After that, it was onward and upwards for Opportunity towards Spirit Point, a point around the rim of Endeavour, an inspiring commemoration of the mission's loss on the other side of the planet. After spending 3 fairly uneventful months at the Santa Maria crater, Opportunity headed towards the closest hill on the crater rim, known as Cape York. Along the way, it came across a few small craters, some of which were very young, with ejecta from the impact strewn across the place. But Opportunity didn't stay for long. Approaching Endeavour, Opportunity was finally able to see some variation in the landscape after years of simply crossing flat plains of sand dunes. Peaks and capes started to rise up on the horizon as Opportunity approached the crater rim. On Sol 2709, Opportunity finally arrived at Cape York, and specifically a place known as Spirit Point, named after Opportunity's sister rover that had come to the end of its mission on the other side of the planet only a few months previously. Opportunity had travelled over 30 kilometers up until this point, 50 times further than the original planned mission distance. Mission planners decided not to go into the crater, as points of interest were again found around the rim of the crater. Bedrock is exposed to the surface there, which allowed Opportunity to study the oldest rocks it had seen so far on this journey. It was also around these peaks and capes along the rim where the hydrated minerals or clays were detected by the MRO. Perched on top of Spirit Point, Opportunity looked over Endeavour, providing a perspective about just how big this crater is. From the onset, Opportunity began discovering phenomena never before seen on Mars. You may remember from the previous episodes that the soil found around the areas Opportunity had thus far explored contained countless smooth, tiny, round rocks, nicknamed blueberries. Around Endeavour, no blueberries were to be found. Instead, the soil looks much coarser, the rocks sharper and not as rounded. Mission controllers were so impressed by the variation of this area compared to the initial landing site that they said that this section of the mission provided the equivalent of a second landing site for the price of one. The first point of interest Opportunity examined was a large ejecta rock called Tisdale 2. It was unlike any other rock so far examined on Mars. It had volcanic characteristics, but contained more zinc and bromine than previously seen. It was determined to be a type of breccia, old rock fragments having been fused together. This was further evidence for water. The impact that threw this bit of ejecta likely released hot underground water that deposited zinc in the rock. Just a short distance from Tisdale 2, Opportunity discovered perhaps the most conclusive evidence that water existed on Mars thus far. Can you guess what it is from this picture? Look closely at the bottom of this image and you'll see a thin white line exposed in this outcrop. A close-up examination of the vein revealed it to be gypsum, the alpha particle X-ray spectrometer on the rover's arm detecting the minerals calcium and sulfur, together making calcium sulfate. They named this vein the Homestake deposit, and it likely formed from water dissolving calcium out of volcanic rocks, which combined with sulfur and was then deposited as calcium sulfate into an underground fracture that later became exposed at the surface. The impact that threw Tisdale 2 likely had something to do with this vein as well. If this is the case, it shows that water once flowed through underground fractures on Mars. Later analysis of the data Opportunity collected showed that not only was this likely to be gypsum, but also that the water here would have been much less acidic than it would have been around other locations on the planet, meaning it could have been more conducive to life. Martian winter was soon setting in, meaning shorter days and a lower sun in the sky. For a solar-powered rover that can't adjust the angle of its solar panels, this is not the ideal situation, but for the first time since the mission began, Opportunity had the opportunity to spend the winter on a slope aimed towards the sun, meaning that for this winter it would be confined to an area named Greeley Haven. This area was not only aimed towards the sun, but it was also rocky, meaning Opportunity had a lot it could examine during these few months. This 360-degree panorama shows the tracks of Opportunity as it carefully navigated its way to its winter lodgings. The fact Opportunity had to wait a few months in one spot was actually handy, as the Musbauer spectrometer in the rover's arm uses radiation from cobalt-57 to determine the composition of a sample. However, cobalt-57 has a half-life of only 9 months, which wouldn't have been a problem for a 3-month mission. Opportunity was now 8 years in, and examining the composition of a rock now took weeks compared to the half hour it would have taken at the beginning of the mission. When it was not examining rocks, it could also use the time to study tiny wobbles in the rotation of Mars to gain insight about the planet's core. It requires weeks of radio tracking the motion of a point on the surface of Mars to measure changes in the spin axis of the planet, something which couldn't be done before as Opportunity was always on the move. The wobbles they were looking for would indicate whether the interior of Mars is still molten or not. Opportunity's weight also meant it could examine the effects of wind on the dunes of Mars from a ground perspective, even at the microscopic level, using the microscopic camera on the rover's arm, checking for slight changes over the months it was stationary. Months had passed, and winter was turning again to summer. On Sol 2947, Opportunity moved again for the first time since it set up camp in Greeley Haven. Luckily, everything that was functioning from before seemed to still be functioning, and Opportunity headed out to the next point of interest. MOR data suggested clays were present in this area, and the mission team were determined to find it. A beckoning outcrop was spotted around Sol 3057, and the microscopic camera revealed something about it that no one was expecting. Much like Opportunity's landing site, these smooth, polished blueberry rocks were observed. However, this time they were very much a part of the rock. They were also smaller than what Opportunity had seen before, only a few millimeters in diameter, and not rich in iron like the landing site blueberries. A few of the exposed blueberries observed had been eroded away, revealing their internal structure. Scientists describe these blueberries as crunchy on the outside and softer in the middle. They are different in concentration, they are different in structure, they are different in composition, they are different in distribution. It was quite the mystery. Opportunity had just one more place to visit on its trip around Cape York, and that was the clay patch dubbed Whitewater Lake. On its way there, the Earth and Mars were just going through a phase called solar conjunction, where Mars is behind the Sun, which blocks communications between mission controllers and the rover. This has happened a few times during the course of the mission already, but this time Opportunity gave mission controllers a bit of a scare, as during the communications blackout, Opportunity's onboard computer reset into standby mode. Thankfully, communications were restored, Opportunity booted back up properly, and it carried on to Whitewater Lake. And it was there Opportunity discovered Esperance, the pale rock in the upper center of this image, which is about the size of a human forearm. This was it, the treasure scientists had been looking for. Esperance's composition was found to be higher in aluminium and silica, and lower in calcium and iron, more so than any other rock Opportunity had examined in more than 9 years on Mars. Testing found that this rock had a clay mineral content due to intense alteration by water. Opportunity spent weeks here, making sure the measurements were correct, getting everything it could get done before Martian winter came around again. Sights were set on a place called Cylander Point, a sun-facing slope on the next hill 1.5 kilometers further south. Opportunity left Cape York on Sol 3344, having spent 9 Earth years, or 5 Martian years, on Mars's surface. It found the best evidence out of any Mars mission that neutral pH water once existed on Mars. Even though this huge discovery had been made, Opportunity still had a lot ahead of it. mission controllers wanted more evidence of water, and they had their sights set on Cylander Point, about 1.5 kilometers further south from Esperance. Martian winter was starting to come around again, which brings with it a reduction in sunlight, from the length of the day to the angle of the sun in the sky. To maximize the generation of power for the little rover, Cylander Point was chosen as it's a north-facing slope, meaning as Opportunity explores the area, its solar panels would be angled towards the sun too. It was also believed to contain more evidence of hydrated minerals and exposed layering in the rocks, as spotted by the Mars Reconnaissance Orbiter. 1.5 kilometers doesn't seem so far away, but Opportunity was a slow rover with a top speed of only 2 centimeters a second, and it often traveled half that just to be safe. Scientists didn't want it to crash into rocks or get stuck in sand dunes, so Opportunity would move forward a bit, look around for hazards, and repeat the process. Along the way, the floor underneath Opportunity looked very peculiar. It was primarily large chunks of rocks, smoothed off at the top with sand and dust filling the gaps, almost like a random mosaic. Flat rocky ground is the ideal terrain for Opportunity, so it made good progress on the way to Cylander Point. Much like the rest of the mission, blueberries were spotted again, rounded rocks a centimeter or two across. By Sol 3390, Opportunity made it to its winter lodgings and began work on the slope. Even while working here, energy production was very low, hitting only 270 watt-hours per day. Any lower than that, and the rover would have gone into a type of hibernation mode. This was due to the Martian winter, but also because dust had been settling on the rover's solar panels, and there hadn't been a cleaning event for a while. This low power mode meant the work around Cylander Point was slow, and it wasn't until Sol 3530 that a cleaning event finally pushed energy production up to 370 watt-hours per day. Cleaning events occur when wind blows extremely fine dust off the panels. Because Mars is so arid, there's nothing adhesive about the dust. So even though Mars's atmosphere is so thin, these dust particles can be easily blown off. A bit like blowing dust off the cover of a book. Dust settles on the rover over time, especially during the massive dust storms that are so big they can be seen from space. Around Sol 3519, Opportunity spent the day examining a surface target. However, embarrassingly, the mesh they used to calculate the distances of objects to the rover was wrong, meaning the instruments on the arm were off by about 5 centimeters. So the images taken were blurry, and the alpha particle X-ray spectrometer couldn't properly detect what it was looking at. This was quickly rectified, and the usual crisp images started coming back to mission control again. A bizarre discovery that was noticed just a few sols later was something known as Pinnacle Island. Opportunity often took days to examine certain patches of ground, but scientists noticed some variation between one photo and another taken a few days later. This rock seems to have appeared out of nowhere. Mission controllers weren't so impressed though, putting it down to a nearby meteorite impact, or even Opportunity bumping the rock into place with one of its wheels. A flyby of the Mars Reconnaissance Orbiter revealed no fresh impact, so that discounted that theory. But mission controllers sent Opportunity on its merry way without investigating the rock further. This caused outrage online, with people suspecting aliens left the rock there as a means of communicating with us on Earth, or that it was a type of fungus that had grown over the 12 days between photos. Some people even went to the lengths of suing NASA over their reluctance to investigate Pinnacle Island further, by imaging it with the microscopic camera on board Opportunity's arm. However, before that really got going, as Opportunity looked back on Pinnacle Island, the mystery was solved. Opportunity had indeed cracked a rock in half, as can be seen by the tracks left in the sand. As far as we are aware, this is the first time something like this has happened on its whole mission, but the chances of it occurring were likely increased as Opportunity's arm was getting less and less mobile through wear and tear. This means that the rover itself now has to turn in order for the arm to reach specific objects, instead of the arm simply reaching across. Another problem that was becoming more and more persistent for Opportunity was the onboard computer randomly resetting. Although Opportunity was always able to turn back on, each reset wasted about a day's worth of science activities. By Sol 3749, these resets caused about half the month to be missed. Mission controllers narrowed the problem down to the onboard flash memory. Flash memory can get temperamental after repeated use, heightening the risk of losing new photos before they can be sent back to Earth, and so the decision was made to reformat the entire drive. This would not only clear the storage, but also identify any bad cells within the drive, so those cells can be avoided in the future. By Sol 3773, the reformatting was completed successfully. Soon thereafter, Opportunity reached Wodowiak Ridge, south of Cylander Point. As this was going on, a visitor from the outer edges of the solar system was hurtling towards Mars. Its trajectory would take it just 130,000 kilometers above the planet's surface before it continued on towards the Sun. This visitor was again not an alien, but Comet Siding Spring, a visitor from the Oort cloud. The Oort cloud is found well beyond Neptune and the Kuiper belt, millions of icy rocks in orbits that take millions of years to complete. Because it had such a long time to accelerate towards the Sun from the furthest point in its orbit, the trip from Mars to the closest approach to the Sun only took 6 days. That's 56 kilometers per second. However, because of the close flyby of Mars, it meant that the spacecraft on and around Mars were actually in a better spot to witness Comet Siding Spring than we were on Earth. Mission controllers of the various missions were also a bit nervous about the dust particles that are ejected from the comet traveling at that speed, potentially impacting and damaging spacecraft in orbit around Mars. As such, Hubble, as well as spacecraft around Mars, all began observations of this visitor. Fortunately, mission controllers had already had some practice at this with Comet Ison, another comet that passed by Mars only the year previously. Comet Ison, however, was 80 times further away than Siding Spring would be, too far and too dim for Opportunity to spot. And unfortunately, it was day just as Siding Spring made its closest approach to Mars, but Opportunity was able to snap a couple of photos of it just before dawn. Can you spot it? Here's the annotated version of the same image. As it passed by, none of the spacecraft were damaged by ejected dust particles, but what they did observe from this flyby was completely unexpected. As it passed by, it plunged Mars's weak magnetic field into chaos, albeit temporarily. Unlike Earth, Mars doesn't have a magnetic field generated from within its core. Its magnetic field comes from plasma high up in its atmosphere, which generates a very weak charge. This is enough to deflect solar wind coming from the Sun, but solar storms from CMEs and solar flares push past this induced magnetic field, stripping away atoms from the atmosphere. Comet Siding Spring had a very similar effect on Mars. Comets are also surrounded by a magnetic field, again induced from interactions with solar wind, this time with the comet's atmosphere, or coma. A comet's coma can reach out for millions of kilometers from the comet, meaning that as Siding Spring passed Mars, Mars was enveloped in its coma for a good few hours. This merged both magnetic fields for the duration of the event, with charged particles from both objects interacting strongly with each other, and the atmosphere of Mars actually lost some particles to space as a result. However, apart from the image Opportunity was able to take from the surface, all this went largely unnoticed by the rover. 2015 was quickly approaching, and Opportunity was heading for Marathon Valley, which would take the odometer reading of Opportunity to the distance of a typical marathon. Completing a marathon in 11 years? That's a pretty impressive finishing time. In celebration of this milestone, mission controllers took part in a relay marathon with a replica of Opportunity as they crossed the 42-kilometer or the 26.2-mile mark. But there was more to Marathon Valley than just a waypoint. There were interesting rocks here that mission controllers wanted to investigate. To get down into Marathon Valley, Opportunity had to go down the steepest slope it had faced yet, 32 degrees. such was the steepness of this slope that dust that had built up on the solar panels began to flow off. After successfully descending down the slope, Opportunity first investigated a region known as the Spirit of St. Louis. It's actually a small crater, yet it has some outcrops exposed. Unfortunately, it was around here that the flash memory caused the onboard computer to reset again. Although mission controllers had narrowed down the problem to a specific cell bank on the flash drive, quarantining this section apparently hadn't completely solved the problem. The solution had helped somewhat though. A reset once a month is a lot better than the few times a day they were getting before the reformatting and quarantining. Eventually though, engineers decided to bypass the flash memory altogether and operate the rover in RAM-only mode. The danger there though was that RAM gets wiped if the computer switches off, meaning any scientific data not transmitted back to Earth is at risk of being lost forever should the onboard computer turn off. The northern edge of Marathon Valley was a ridge named Henners Point. To the south was a ridge named Knudsen Ridge. In these regions, Opportunity was again looking for clays, past evidence of liquid water oceans on Mars. Mission controllers detected clays on these ridges from orbit with the MRO, which correspond to these reddish areas seen in the enhanced color versions of these photos. Opportunity found these rocks to be brittle and to disintegrate a lot easier than other rocks it had previously observed, as well as having unusual compositions. They were unlike a lot of other rocks in the area. Although data collection was constant here, it was also extremely slow going. The alpha spectrometer on Opportunity's arm was losing its potency, meaning sample analysis that would have taken minutes at the beginning of the mission would now take in days or weeks. This was also combined with Opportunity's temperamental onboard computer, which was really starting to struggle. As a result, it took Opportunity well over a year to get through Marathon Valley. It began to head deeper into Endeavour and was greeted with a spectacular sight. A dust devil was spotted on the crater floor. Spirit, Opportunity's sister rover, had seen dust devils in the past, but they were a lot rarer for Opportunity. It is believed that dust devils passing over the rovers had been responsible for the occasional cleaning events that removed dust off the rover's solar panels. Opportunity's next goal was again found further south, a gully that scientists believe might have been carved out by water. A gully had never been closely examined by a Mars mission in the past, so scientists were excited by what they might find. But getting there was tricky. On its way down the crater rim, it passed through a gap in this ridge named the Lewis and Clark Gap, down Bitterroot Valley to Spirit Mound. On its way down, it took some spectacular panoramas of various ridges overlooking the sand dunes stretching across the crater floor. Upon reaching Spirit Mound, Opportunity had been on Mars for well over 4,500 sols, roughly 12 Earth years. All things considered, Opportunity was in reasonable health, and generating a very comfortable 450 watts of power from its solar panels. On its way to the gully, it would stop periodically to perform some science operations, like imaging select rocks and measuring argon in the atmosphere. Opportunity finally reached the gully in September 2017. The gully was named Perseverance Valley. Scientists wanted to know whether it was water, ice, or wind that had carved this gully. From the shape of the gully, it certainly looks to have had something flow down it. Opportunity also spotted rocks aligning the channels. Could these have been deposited by water currents? As it turned out, Opportunity wasn't able to find anything conclusive. After several months of examining the area, Opportunity passed through 5,000 sols on Mars. And what better way to celebrate than by taking its first full selfie? You'll notice this image is blurry. That's because it was taken with the fixed focus microscopic imager on its arm. It was only designed for very close targets. In June of 2018, the MRO detected the formation of a dust storm. This isn't unusual. Mars has seen its fair share of dust storms coming and going on a fairly regular basis. Opportunity had even lived through some itself. However, within days of its formation, it was clear that this was going to be a big one. It very quickly spread across the entire planet, and mission controllers began preparations for a period of low power. On the 3rd of June, Opportunity was producing 468 watts of power. By the next day, this had dropped to 345 watts. By the 6th of June, it had plummeted to 133 watts. Dust caught up in this storm filled the atmosphere, obscuring the precious light from the sun to the point where it would have barely even been visible. The worst storm Opportunity had experienced up until this point was in 2007, where the atmospheric opacity, known as a tau value, was at 5.5. This was almost enough for Opportunity to not make it through. This storm, on the other hand, had a tau value of 10.8, almost twice as bad as the previous storm. Although operations were kept very basic, only sending back health reports every morning and evening, by the 12th of June, Opportunity fell into a continuous hibernation mode. The storm dragged on for months, and with each passing day, mission controllers lost more hope that Opportunity would wake up on the other side. 3 months later, the storm finally subsided enough for Opportunity to wake up from its hibernation mode, and efforts were made to re-establish contact with Opportunity. By October, the storm had cleared completely, but no contact had been made with the rover, even after 350 attempts. From November on, mission controllers hoped that if the rover simply had a lot of dust on its panels, that wind would blow a lot of it off. However, 1,000 communication attempts later, all the way through to February, mission controllers gave up hope and declared the mission dead.
MER project off the net.
The 15-year, or 5,352 Sol Mars mission had finally ended. And what a mission it was. Opportunity measured temperatures, atmospheric readings, the rotation of Mars, and more. However, the real prize was the definitive proof that Mars was once a world similar to our own, in that it held stable bodies of liquid water oceans on its surface in the distant past. While we may take that for granted now, when it was first confirmed, it was truly groundbreaking. Shortly before communication was cut off, Opportunity was in the process of sending back one last panorama of its final resting place. Its famous last communication was poetically translated to be, "My battery is low and it's getting dark," and its final image was of the sun obscured by the dust. And there we have it, a recap of the entire Opportunity mission. Thanks for watching, and a big thanks to my patrons and members for continuing to make videos like these possible. If you want to support Astrum too, find the link in the description. Subscribing and liking also goes a long way if you want to support in other ways. All the best, and see you next time.